Hello everyone, welcome to our sessions. In this series of videos, we are going to cover 9 chapters of Pure Mathematics 1. Chapter 2 is Quadratics. In this video, we are going to cover functions and quadratic graphs. We will be going through each topic with examples and some book exercise questions step by step. We will also solve some past paper questions. We'll be discuss some tips on how to avoid making mistakes so you can excel in your Excel. Let's start our journey. First topic is functions. To understand function, very easy thing is, suppose you have one machine known as function. You are putting here input, and as a product what you are getting, which is output. So function is nothing but a machine. You are putting input, you are getting something output. A function is a mathematical relationship that map each value of set that we are telling as inputs to a single output. The set of possible input that we are telling as a domain, and the output what we are getting that we are telling as a range. Here we mapped function f(x) is equal to x squared. So when your input is 3 squared is 9, so your output is 9. When your input is 7, output is 49, 7 squared 49. If your input is minus 7, your output is 49 because minus 7 squared is also 49. If you put 1 over 4, output is 1 over 16. Root 2 squared is 2, so 2 you are getting it. So this is where function is working. Now, if you want to find root of functions, like equations, we have to put f(x) is equal to 0. And we are using f of x, g of x, or r of x, something like that to represent functions. Okay. Move to exercise 2e. Using the function f of x is equal to 5x plus 3 and g of x is equal to x squared minus 2 and h of x is equal to root x plus 1. Find the value of f4 and g2. To do this question, first we have to substitute value f4. That means whenever there is a x is there, I have to put 4. So my x is 4 here. When you simplify, 20 plus 3 will give you 23. Now we are finding g2. So that means 2 squared minus 2. 4 minus 2, 2. Now put in this equation or in a function, f of 4 plus g of 2 is equal to 23 plus 2 will give you 25. So this is our answer for this question. Move to next question. The function f and g are given by f of x is equal to 2x cubed plus 3x and g of x is equal to 17x squared. Find the 3 value of x for which f(x) is equal to gx. So we know two functions are there and we know these two functions are equal. We have to find value for x. Okay. So we know f of x is equal to g of x. Both functions are same. So I can write 2x cubed plus 3x is equal to 17x squared. Now to simplify further, we have to take 17x squared this side. So 2x cubed minus 17x squared plus 30x is equal to 0. Now it's simple like solving equation. You can see x is a common factor. So 2x squared minus 17x plus 30 equal to 0. As we have to find 3 values, the first value I get, which is x is equal to 0. Now to get 2 other value, we have to factorize this equation. To factorize this equation, now you know how to factorize this quadratic expression. So you can get to factor 2x minus 5, x minus 6. I'm not going in a detail. Here you can do splitting middle term or you can use quadratic formula to do that thing. So we are getting 3 factors here. Now to find the values, I will equate each factor with 0. So x is equal to 0, 2x minus 5 equal to 0 and x minus 6 is equal to 0. 2x is equal to 5, and x is equal to 5 over 2 divided by 2, and here plus 6 both side, so x is equal to 6. So here we are getting 3 value of x is equal to 0, x is equal to 5 over 2, and x is equal to 6. Move to question number 8. The function f is defined, f of x is equal to this, x belongs to R. Write f of x in the form of this one. So basically we have to factorize this function. To make this thing easy, we can use little bit trick here. This is my function. Now with this is little bit look complicated. So to make it easy, I am rewriting it as a 3 power x squared, 28 3 power x plus 27. Now as you can see here, 3 power x I can assume as y. So it's y squared minus 28y plus 27, that my normal function is there. Now factorize it. So I will get two factors which will y minus 27 and y minus 1. Now I can resubstitute this value here. So 3 power x minus 27 and 3 power x minus 1. So this I got in this form. So this is my a and this is my b, which are the real constant is there. Now part B. Part B, we have to do roots of f of x. How we can do that? To find the roots, we know we have to write equal to 0. So I can write 3 power x minus 27 equal to 0. So 3 power x is equal to 27. Now to find value of x, in indices we used to do that. I can write 27 as a 3 cubed. And if the base is same, x is equal to 3. I can write power is same. This is the first root. Second root is 3 power x minus 1 equal to 0. So 3 power x equal to 1. Now how we can write 1 as a power of 3? So I know anything power 0 is 1. So that means 3 power 0 is equal to 1. So x is equal to 0. Same base we can equate power. So we are finding two roots of fx, which is x is equal to 3 and x is equal to 0. Next topic is quadratic graphs. So when I have a function f of x is equal to ax squared plus bx plus c, the graph, the shape of the graph we can say is a parabola. And the coefficient of x squared determine the shape of a graph. For example, if my a is positive, suppose I have a function y is equal to x squared minus 5x plus 4. Here my a is positive, so shape of my graph is look like this. Suppose my a is negative, y is equal to 4x minus 2x squared minus 3. My a is minus 2. Then shape of my graph is look like this. So these two shape we are telling as a parabola, depending on what type of function you have, positive function or a negative function. Now to draw a graph, we have to keep in mind these three things. First, we have to find y coordinate. Means where our graph is intersecting y-axis. To find that, in our function, we have to substitute x is equal to 0. So that will give you coordinate. Second, to find when the graph is intersecting our x-axis, we have to substitute y is equal to 0. And because of this is quadratic functions, we are getting two values for x. So we are having a two coordinates for x. Here we are getting one coordinate. And third and very important, in these two type of a graph, for this graph, our turning point, we can say it's a minimum. And for this kind of graph, our turning point is maximum. And to find this turning point, we have to use our completing squared method that we did in last topic. Now another thing very important, this graph we are considering is a symmetrical graph, and as you can see it is symmetrical. So we can find a line of symmetry for this graph. So whatever our turning point is there, the x coordinate of the turning point, that will give us line of symmetry. We will do this with an example, so that will make you more clear. As we discussed, to find the coordinates of the turning point, always we are using completing the square method. In that, our functions we have to convert it in this form. For example, I have a function f of x is equal to x squared minus 5x plus 4. So convert it into completing square form. So I know this is my b. I have to do b over 2. So x minus 5 over 2 squared minus b squared plus 4. See as it is. So x minus 5 over 2 squared minus 25 over 4 plus 4. Use calculator to simplify it. So you will get minus 9 over 4 here. Okay. Now to compare with this form, so I can write it down a x plus p squared plus q. Now here a is 1, so we don't have to worry. But the turning point coordinate we need minus p and q. Means this p should be with the opposite sign and q we need it. Now for this graph our coordinate is, because minus 5 by 2 is there and we need minus q. So we have just 5 over 2 and q as it is with the sign, so minus 9 over 4. So these are our coordinate of a turning point for this function. So always use completing square to find the turning point. Let's move to exercise 2F. First question, sketch the graph of following equations. We have to find the coordinate of points where the graph crosses the coordinate axis, which is x and y. We have to write coordinate of turning points and we have to find line of symmetry. We are doing question H. Y is equal to 6x squared minus 19x plus 10. This function, as you can see, our A is positive. So this is the shape of our graph. That's the first thing we can figure it out. Second thing, to find where it intersecting y-axis, we have to substitute x is equal to 0. So y is equal to 6 0 squared minus 19 0 plus 10. So that will give us 10. So the coordinate is 0 10. To figure out where this function is intersecting x-axis, we have to substitute y is equal to 0. So that means 6x squared minus 19x plus 10 equal to 0. To solve this for finding x, we have to simplify it. So for that, you can use either quadratic method or you can use splitting middle term. But quadratic is better. We learned last video like how to solve this by using a quadratic formula. So x is equal to, we are getting 5 over 2 and x we are getting as a 2 over 3. So the coordinate what I am getting is 5 over 2 0 and 2 over 3 0, right? So these two informations we are getting it. Now to find the coordinate of the turning point, in the next part I am showing you. Before that, how to draw graph. So this is our axis. So this is our y-axis, this is our x-axis. This point which is I am labeling is 0 10, where my graph is intersecting y-axis. And the two other point that I am getting it here, which is this point, which is 2 over 3 0, and this point is 5 over 2 and 0, right? And this is 2 over 3 0, right? Now try to make a shape. So our graph start like this. So these two information we have. Now the next part is find the turning point. Okay. So to find the turning point, we have to use completing squared method. So first we will finding out this function as a completing squared method. So this is our function f of x is equal to 6x squared minus 19x plus 10. To find completing square, I have to remove this 6 first. So x squared minus 19 over 6 plus 10, right? Now to write it down this part, sorry, x should be here, 6, Now this is my b. I have to do b divided by 2. So x minus 19 over 12 minus 19 over 12 squared plus 10. So this is my completing square steps are there. So 6 into x minus 19 over 12 squared minus, this is 361 over 144 plus 10. Open bracket, 6 into x minus 19 over 12 squared minus, this multiplied by 6 is giving me 2166 over 144 plus 10. When you simplify, x minus 19 over 12 squared give you minus 121 over 24. You can use calculator for all this simplification. Now this is our completing squared. Now comparing with p and q. So this is my p and this is my q. Actually this is my minus p. So that way we can find it out coordinate. So coordinate of my turning point I will get is minus 19 over 12 and minus 121 over 24. Now the third part, to find the line of symmetry. So to find the line of symmetry, we have to use x coordinate. So you can write x is equal to 19 over 12. So this is our, we can say, line of symmetry. So if you want to complete this graph, you can write here 19 over 12 and minus 121 over 24. So that will show you the turning point. And if you want to label it, you can draw the line of symmetry. Sorry, my line is not straight. Something like this. Okay. So this is where we can figure out this whole question. So first we have to find where coordinate for y-axis, coordinate for x-axis, then the turning point, and then the line of symmetry. Question 2. This sketches our graph of a quadratic functions of ax squared plus bx plus c. Find the value of a, b and c for each function. We are going to do question b. So as you can see here, graph is given to us and we have to find a function for this. So first, whatever information which is given in graph, we are writing down. So we can say the first coordinate we are getting is 0, 10. So that for the y-axis is there. Right? This is for y-axis. For x-axis, we are getting two coordinate which is minus 2, 0 and 5, 0. This is for x-axis. Right? Okay. So, and as you can see the shape of the graph, it has a maximum value. That will tell us our a is negative. So, to find it out function, we can put these two x coordinate with the opposite sign like x plus 2 and x minus 5 equal to 0. And as I am telling you, this is maximum value, so I have to put negative here. Now expand bracket. So x squared minus 5x plus 2x minus 10 equal to 0. Multiply whole bracket with a minus sign. So minus x squared plus 5x minus 2x plus 10 equal to 0. So minus x squared, 5x minus 2x will give me plus 3x plus 10 equal to 0. So find the value of a, b, c. Compare it. So my a is equal to minus 1, my b is equal to 3 and my c is equal to 10. So if you know your y-intercept and your x, you can figure it out what your function is or what function this graph is about. Next question is the graph of y is equal to a squared plus bx plus c has a minimum point 5 minus 3 and passes through 4, 0. Find the value of a, b and c. Now we know the minimum point. So we know this is our minus p and this is our q. So we can write this in a general form. F of x is equal to a into x minus p, that means minus 5 squared minus 3. So this is our p and this is our q. Now, to find value of a, we can use our this coordinate. So in this, we can substitute 4 instead of x, and we can substitute y is equal to 0. That will give us the value of a. So I can write 0 is equal to a, 4 minus 5 squared minus 3. 0 is equal to a, 4 minus 5 minus 1 squared is 1, minus 3. So a, I am getting 3. So now I got value of a. So I can write this function by substituting value of a. So my f of x is equal to 3x minus 5 squared minus 3. Now to write in this form, I have to expand it. So 3 into x minus 5 into x minus 5 minus 3. So 3 into x squared minus 10x plus 25 minus 3. If you want, you can do in bracket. So 3x squared minus 30x plus 25, 75, because 25 times 3, which is 75, minus 3. So 3x squared minus 30x plus 72. So this is our A, B and C. So as you can see, this is my A, this is my B, and this is my C. So you can put A is equal to 3, B is equal to minus 30, and C is equal to 72. So that's our answer. Let's move to past paper questions. Question is telling on diagram 1, sketch the graph of these two functions. Now, first we have to figure it out. This is positive or a negative function. So as you can see here, if you expand, that will give us y is equal to 3x minus x squared. So it's a negative function is there. So our shape of a parabola is like this. If you multiply this bracket, y is equal to, and you can, there is a negative axis there. That means this is also negative cubic graph is there. So negative cubic graph is look like this. Okay. So now by using the coordinate, we will draw properly. So first, for first function, we have a two value, x is equal to 0 and 3 minus x is equal to 0. So x is equal to 3. So we have a two coordinate 0 and 3. For second function, x is equal to 0, x is equal to 2 and x is equal to 5. So that means we have a 3 intersection point of function fx. So it looked like this. So this is our function, which is a cubic function, which is, as you can see here, this is x is equal to 0, x is equal to 2 and x is equal to 5. So we can have 3 intersection point 1, 2 and 3. And now another graph parabola, it is for question this one. So this one is equal to y is equal to x into 3 minus x. So as we can see, we have a two coordinate, x is equal to 0 and 3. So you can say this is 0 and this is 3. So this is for this function is there. So this way we can draw this graph. So you have to do practice of drawing this graph. Okay. Question, the curve C1 has equation 3x squared plus 6x plus 9. Write this in the form of a into x plus b squared plus c. Now this is completed squared form is there. So we will try to convert our function in this form. So y is equal to 3x squared plus 6x plus 9. Okay. So first I will take 3 common. So we have x squared plus 2x plus 9. This is my b, divide by 2. So x plus 1 whole squared minus 1 squared. Put this into bracket plus 9. Expand bracket. So 3 into x plus 1 squared. Minus 1 squared is 1, multiplied by 3 will give me 3 plus 9. So 3 into x plus 1 squared plus 6. Okay. So this is our form. So this is my A, this is my B, and this is my C. So in this form is there. So it's to be found. So we find A is equal to 3, B is equal to 1, and C is equal to 6. Now second part. The point P is the minimum point of C1. Deduce the coordinate of P. So as we know, when we do completed square, our minimum point is minus P and Q. So my P is 1, so I can write minus 1, and my Q is 6. So this is my turning point for this function. Move to next question. In this question, point P and Q are shown in figure. So these are the coordinate of point P and Q. The straight line L1 passes through P and Q. Find an equation for L and writing your answer in form of y is equal to mx plus c. We have to find the equation of line. For that, first we have to find the gradient. So my coordinate is minus 2, 13 and 4, minus 5. So this is my x1, this is my y1, this is my x2, this is my y2. The formula to find the gradient m is equal to y2 minus y1 over x2 minus x1. So that means minus 5 minus 13 over 4 plus 2. So when you simplify, it will give you minus 3. So gradient for this line is minus 3. Now we have to form equation in form of y is equal to mx plus c. We can use this formula y minus y1 is equal to m into x minus x1. We use this in IGCSE, so you must know this. So y minus 13 is equal to minus 3 into x plus 2. Minus 2 minus minus become plus 2. So y minus 13 is equal to minus 3x minus 6. I have to move 13 this side because I need y is equal to, so minus 3x minus 6 plus 13. So y is equal to minus 3x plus 7. So this is my equation of line y is equal to mx plus s. This is my gradient, this is my y-intercept. Okay. Let's move to part B. The quadratic curve C passes through point P and has the minimum point at Q. Find equation of C. So we are finding equation for curve. And I know Q is a minimum point. I know the coordinate of Q, which is 4 and minus 5. So I can use completed square method. So I can make equation y is equal to, we don't know value of a here, and x minus 4 squared minus 5. Because this is our P and this is our minus P and this is our Q, right? Now, to find the value of A, we can use any other coordinate, which is coordinate P. So coordinate P is minus 2 and 13. So I am putting here 13 is equal to A, minus 2 minus 4 squared minus 5. So minus 13 A, minus 2 minus 4 minus 6 squared minus 5. 13 is equal to A, 36 minus 5. When you simplify, take 5 this side. So 36A is equal to 18. So A is equal to 18 over 36 will give you half. So this is my value of A. I will put this here in a equation. So y is equal to half x minus 4 squared minus 5. So half, expand x minus 4 6 will give me x square minus 8x plus 16 minus 5. Multiply whole thing with half. So half x squared minus 4x plus 8 minus 5. So half x squared minus 4x plus 3. So this is my final answer. This is equation of a curve that we are going to find it out. Move to next question. In this question, we have a curve C and this is the equation of curve C. The point M is the maximum turning point of C. So as you can see, this is the maximum point. You have to rewrite this equation in form of this, means completed square, and then we have to find coordinate of M, means we have to find turning point coordinates. Okay, start. So y is equal to 4 plus 12x minus 3x squared. Now when we have a negative function, so always we have to rearrange them first. So minus 3x squared plus 12x plus 4. So here y is equal to minus 3, I am taking common, so that will give me x squared minus 4x plus 4. So x minus 2 squared minus 2 squared plus 4. So minus 3 x minus 2 squared is 4. 4 times 3 which give me 12. But my negative and negative is plus 12 plus 4. So minus 3 x minus 2 squared plus 16. So now rearrange it. So I can write it down 16 minus 3 into x minus 2 squared. Now to find it out the coordinate, we know this is my p minus p and this is my q. So for that I know my coordinate is 2, 16. So these are the coordinate of this. From here you can find minus p is equal to minus 2. So p is equal to 2 and q is equal to 16. So these are the coordinate for the turning point. Next part of this question is the line L2, it's not shown in figure, passes through O and M, shown in the figure 4, and line L2 touch C and is parallel to L1. We have to find equation for L2. Now to find equation for L2, because it's a parallel, we have to find equation for line L1. For that, we have to find gradient for L1. For that, I can use this and this coordinate. So I can find it out 16 minus 0 over 2 minus 0, which is equal to 8. So equation for line L1 is equal to y is equal to 8x plus k. We don't know k, so we can just put as a. So for line L2 also, gradient is 8 because it's parallel, so they have a same gradient. Now another thing, line L2 touch C, means they have one common intersection point. So to find that, we can equate this to equation of curve and the equation of line. So it's 4 plus 12x minus 3x squared, which is equation of curve, is equal to 8x plus k. Simplify it. So what I am doing it, I am taking everything this side. So minus 3x squared become positive 3x squared. So 3x squared minus 12x plus 8x minus 4 plus k. So as you can see, all these terms sign will change because I move to another side, right? Okay, simplify it. So 3x squared minus, I am taking x, minus 12x and plus 8x will give me minus 4x minus 4 plus k equal to 0, right? Now we don't know value of k, so we cannot simplify it further, but we have a one hint here. They are telling touch C, means they are intersecting at one point. In that case, b squared minus 4ac is equal to 0. So I can use this to find value of k. So this is my A, this is my B, and this whole thing is my C. I am putting this into equation. So 4 squared minus 4a minus 4 plus k equal to 0. So b square minus 4ac, I put it like this way. So 16 minus 4 times 3, 12, minus 4 plus k equals 0. So 16 minus 12 times 4, which give you 48, and minus minus plus 48 minus 12k equal to 0. When you simplify, you will get 12k is equal to 64. So k is equal to 16 over 3. You simplified it, 64 divided by 12. So I will get this value of k. Now I will substitute in my equation of line. So the equation for line L2 is equal to y is equal to 8x plus 16 over 3, which is in a y is equal to mx plus c form, right? Okay. Takeaway for this topic is we are telling input as a domain and output as a range. So in your functions, input are given and you have to find the output. So for example, if I have a function f of x is equal to x squared. If my input is 2, then I have to do 2 squared, that will give me 4. So 4 is my range or my output. If you want to find a root of a function, always rewrite equal to 0, factorize left hand side and find the value of that function. For example, if I have a 2x squared plus 4 is equal to 3x. So first I have to rearrange 2x squared minus 3x plus 4 equal to 0. Then I have to factorize it. Then write equal to 0 and solve it. How we are using solving equations. Always substitute value in bracket. For example, if I have x squared, g of x is equal to x squared minus 2. And if I want to find g of minus 2, then I have to put minus 2 squared minus 2. That will give me 4 minus 2, 2. If I will not put bracket here, we end up with the wrong answer. That will give me minus 2 squared minus 2. That will give you minus 4 minus 2 minus 6 answer, which is wrong. To find a turning point, always we have to rewrite the function as a completing square. So in that case, suppose my function is ax squared plus bx plus c. Then I have to rewrite as a into x plus p squared plus q. So minus p and q is my turning point. So whatever answer is here, change sign and put this q as it is. That will give you the turning point. Thank you for watching this video. If you find this video helpful, please give it thumbs up. Do subscribe for more math content and let me know in the comments if you have any questions or topics that you would like to see next.